Welcome to this video. We're going to look this time at how we can convert a decimal value to a binary number. Let's start with our decimal value, the number 74. We may not have looked at this notation before. We have the number 74 and the little 10 down in the bottom right hand corner. That little 10 is telling us that this is a base 10 number or a decimal number. This can be very important as we start working with binary a bit more, because sometimes we can't easily tell whether we're talking about a binary number, for example, or the number 100, because they look the same, ones and zeros. So we should get used to representing the base of a number if there's any chance of being confused. So for the moment, I'm showing that this 74 is a base 10 or a normal decimal number that we're familiar with. So how do we go about actually turning this into a binary number? Now there are a couple of different ways to do this. The one I'm going to show you here I think is the simplest way when you're first learning, but there's a really good division method that's especially good if you need to maybe put this into some sort of computer program or formula to work out what the binary is. But for our case, we're not going to look at that one today. You might want to investigate this version later on yourself. We might have some links provided as well. But for now, we're just going to go through a simple subtraction method. So we're going to start by bringing up our place values for binary, the 1, 2, 4, 8, 16, and so forth. I'm only doing the first 8 places, and you'll see why in just a moment. So what we want to do is we want to take our decimal number that we have, and we want to start by finding the biggest possible binary place value that we can that doesn't go past our number. So we got 74. We obviously can't use 128 because that is too big. So the biggest number that we can get there is 64. So 64 is the biggest place value that we can use without going past the actual number being 74 at the moment. So because I can use that place, I'm going to put a 1 in that spot. To work out the next step, I have to work out a quick equation, which is going to be the number I have being 74, take away the place value that I have, 64, which gives me 10 left over. So I'm going to repeat this process again now with the number 10, the leftover amount. So I'm now looking for the next biggest number that I can use from my binary without going over my number 10. So the next biggest number I can do is the number 8. 8 being the biggest number without going past the number 10. So again, I'm going to put a 1 in this column. Do my math, so 10 minus 8, so the number I had minus the place value in binary I've just chosen is going to leave me 2. So one more time, I'm going to find the biggest number that I can from my binary without going past my number. So the biggest number here, 2, is in fact 2. So I'm going to put a 1 there, and I'm just going to do the math to be sure. So I had 2, I'm going to take away 2 for that binary column, which gives me 0, which means I don't have anything more to fill. So at this point, I now just fill in all my empty spaces with zeros. So in the 1s, the 4s, the 16s, and the 32s. I don't need to put it into the 128s. Just like in decimal, we don't need leading zeros necessarily. There will be times that we do, and we'll talk about those in future videos. But for now, just to show that binary number, I don't need to have one at the start of this binary number. I do have to make sure, however, that I did fill in the 1s, because if I didn't, that would have made the place values different, and of course the number would be incorrect. So the number 74 in base 10, again showing with that little 10 there, is equal to 1001010 in base 2. Let's have a look at a second example. So here I have 219 in base 10, so 219 in decimal. Let's throw up our place values again. So I'm going to start by looking for the biggest number that I can fit into 219 without going over. Now we might think, hang on, is 128 the best one? So let's have a think. So if we went to the next place value, would actually go to 256. So 128 doubling would be 256. And of course 256 is bigger than 219, so that's not useful to us, so we actually don't need it at all. So in fact, 128 is the biggest number that we can fit into 219 without going over it. So we put the 1 in there and we do our math. 219 minus 128 leaves 91. So looking back again, what is the biggest number that I can now fit into 91 without going over? So again, 64. So I'm going to put my 1 in 64. I'm going to do my math again. So 91 minus 64 gives me 27. So now I've got 27. The biggest number I can fit is 16. So I'll put a 1 in there. Do my math. 27 minus 16 is 11. And we keep going. So the biggest number I can fit in here is the 8. So let's put the 1 in there. Do our math. 11 minus 8 being 3. Biggest number I can fit into 3 is 2. So let's put a 1 in there. Do the math. 3 minus 2 is 1. And of course, the only number I've really got left anyway is a 1, and that is the biggest number without going over. So yes, I'll put a 1 in the ones column. I'll do the math. 1 minus 1 is 0. I have nothing left to fill in except, yep, my zeros. So in this case, 219 in decimal in base 10 is equal to 1101111 in binary or base 2. So that method is how you can go about converting a decimal number or a base 10 number into a binary number. As I said, there is another great way where you do division with remainders. It's really, really efficient, but again, it's something you can either investigate for yourself or we might do another video in a future situation for that one. Thanks again for watching and go have a try at those.